In 5.2 it is given to you A is equal to 60 degree, and it is given that B is equal to 30 degree. So you need to verify that tan A minus B is equal to tan A minus tan B by 1 plus tan A tan B. So you start with the left hand
Good
side.
morning, sir.
Good morning. Tan A minus B. What is tan A minus B? It is tan of the values of the angles are 60 degree and 30 degree, which is equal to 60 minus 30 is 30. So tan 30. And what is the value of tan 30? Tan 30 is the lower value between 1 by root 3 and root 3. So it has to be 1 by root 3. Right hand side. Tan A minus tan B by 1 plus tan A tan B. Put the values here. Tan 60 degree minus tan 30 degree divided by 1 plus tan 60 degree tan 30 degree. Now put the values. Tan 60 is root 3 standard value. Tan 30 is 1 by root 3 divided by 1 plus tan 60 is again root 3 and tan 30 is 1 by root 3. So what happens here? This root 3 and this root 3 they cancel. And here you take root 3 as your LCM in the numerator. If you take root 3 as your LCM, what are you left with here? Root 3 into root 3, right? Because you have a 1 here. Root 3 divided by 1 is root 3. And you multiply that root 3 by this root 3. Minus root 3 divided by 1 plus 1. So root 3 into root 3 is 3. And 3 minus root 3 by 2. Oh, by there's another root 3 there. Okay, so you have this root 3 also. So you have 3 minus, this should not be root 3, this should be 1. Because root 3 by root 3 is 1. And 1 into 1 is 1. This is 3 minus 1 by root 3 divided by 2. So this is 2 by root 3 divided by 2. Which is 2 by 2 root 3. This and this cancel, so you get 1 by root 3. So you get left hand side is equal to right hand side, hence verified. Left hand side and right hand both the values are 1 by root 3. So verification problems are in fact very easy. You just put it on the left hand side and you put it on the right hand side and you verify them to be equal. Okay, next this one, number 6. Now number 6 is something that I have done earlier also, that is in the previous exercise, and I told you that this problem can be done actually in 2 ways. At that time I had told you. Okay, but since I had not discussed the standard ratios back then, so that is why I could not show you this method. Now I'll show you this method. In fact, I'll show you the difference between both the methods also. See here it is given that theta is an acute angle, and therefore sine, and also given that sine theta is the same as cos theta. Sine theta is equal to cos theta. So therefore you get sine theta by cos theta is equal to 1. So you get tan theta is equal to 1. Okay. Now you can proceed in two ways. The first way that we were doing in the last exercise that we did. How are we doing? We are drawing a right angle triangle, right? We were drawing a right angle triangle, and then what were we doing? This tan theta is equal to 1 means if I take this angle as my theta, that means perpendicular. This become my perpendicular. This become my base. This is a right angle triangle, so this is my hypotenuse. This means perpendicular by base is equal to 1. That means AB by BC must be equal to 1. So the ratio is 1. So I can take AB is equal to K, and I can take BC is equal to K. And then by Pythagoras theorem, BC square is equal to AB square plus BC square. And K square plus K square means 2K square. Therefore BC is root over of 2K square, which is root 2K. Okay, so you have got this as K, this as K, and this as root 2K. So therefore question here is find the value of 2 tan square theta plus sine square theta. The tan theta you know, therefore we only need to find out the value of sine theta. Let us first find the value of sine theta. What is sine theta here? Sine theta is equal to perpendicular by hypotenuse. Perpendicular here is k, hypotenuse here is root 2k. So k and k cancel, you simply get 1 by root 2. So now what is the expression you need to find out the value of? You need to find out the value of 2 tan square theta plus sine square theta minus 1. You need to find out the value of this expression. Substitute the values. Tan theta, how much do we know? We know tan theta is equal to 1. So 2 into 1 square. And sine theta we have calculated 1 by root 2. So sine square theta will be 1 by root 2 square minus 1. Okay, so this one now is 2 plus half minus 1. Now you can take the LCM. This is 4 plus 1 minus 2. This is 5 minus 2 divided by 2, which is 3 by 2. So you are getting the value of this expression as 3 by 2. But this method of working out we have seen in the last exercise. This time we are going to modify this method because we know some standard values. Okay, so we're going to do a little bit of this same problem. We are going to do a little bit differently. We are not going to draw a right angle triangle. Okay, in fact we are going to do directly. In fact this is an easier method. You don't need to work so much. So given here is sine theta equal to cos theta. That means sine theta by cos theta is equal to 1. That means tan theta must be equal to 1. And what value of tan is 1? If you see, go back to the tables. What value of tan theta is 1? This value is 1. And what degree that is correspond to? So tan 45 is 1, right? So therefore, coming back here, instead of 1, we can write here On the right hand side, instead of 1, we can write this as tan of 45 degree. So therefore, what happens? Now we can write theta is equal to 45 degree. Now remember, this does not mean that this tan and this tan they cancel. No, tan theta is equal to tan 45 does not mean that tans are cancelling. You cannot cancel. Okay, tan theta is equal to tan
Is there
45.
in this tan?
Huh? Tell me, what were you saying?
Because tan it is
Your voice is cracking. But anyway, the what I mean to say here is that you cannot cancel both the tans on the left hand side and the right hand side. Okay, you cannot cancel the tans. So you see, after this step, you can simply write theta is equal to 45 degree. But it does not mean that tan and tan cancel each other. Okay, so most of the people they make this mistake. So once you get theta is equal to 45 degree, then this is very easy to find. What is the value of the expression you need to find? 2 tan square theta plus sine square theta minus 1. You put theta is equal to 45 because we have already found theta is equal to 45. The 2 tan square 45 plus sine square 45 minus 1. Now 2 tan square 45 means tan 45 degrees square plus sine. Remember, I am writing this only this sine square 45 and sine 45 degree repeatedly in the notes I have clarified. Okay, repeatedly in the notes I have given you each and every step. But while working out here, I will not show you since this is only the beginning. That is why I am showing you this work. That sine square 45 is sine 45 square. So this is only the beginning. That is why the next time I'll simply write the directly the values. So 2 tan 45. You know the value of tan 45 is 1 square plus sine 45. The value here is 1 by root 2. Okay, so now this becomes 2 plus half minus 1. Now you can take the LCM. 4 plus 1 minus 2. So it's 5 minus 2 by 2, which is 3 by 2. So you've got 3 by 2 earlier also, 3 by 2 here also. But you see the difference in the methods. There we were drawing a right angle triangle, finding the hypotenuse, then we were determining all the ratios. Then we found out the value of sine theta, and then we put the values. But here we are finding the value of theta because we know the standard value of theta. Theta is tan theta is equal to 1 means theta is equal to 45 degree. That is why we put it here, and this became a more simple way of doing. Okay, so this one is also very similar to the one that I have worked out. Okay, except here that you have 4 cos square x given here, 4 cos square x degree minus 1 is equal to 0. And it is given that x lies between 0 and 90. X lies between 0 and 90 actually means that, as I told you in the beginning only, that x lies between 0 and 90 means, what does this mean? This means that x is acute. That means all the trigonometric ratios are positive. That is what it means. So therefore, you can find out the value of cos from here. So you have cos square x degree is equal to 1/4, and therefore you have cos x degree is equal to square root of 1/4. Now remember, we will not give a minus sign because, as I told you, theta is acute. All the trigonometric ratios are positive. So we only take the positive ratios. So this becomes half. So what value of cos is half? Let us go back to the table and see. See here, cos. This is your row for cos. And what value is half? We can locate the value half here, right? And you know that cos 60 is half. So therefore, instead of half, I can write here cos 60. So that means what does x become? X becomes 60 degrees. Now you can find out whatever value you want. So this one was part 1. If find the value of x. Part 2 is sine square x degree plus cos square x degree. Again, sine square x degree can be written as sine x degree whole square. Cos square x degree can be written as cos x degree whole square, which is sine x degree whole square means sine 60 degree whole square and cos 60 degree whole square. Sine 60 degree means what is the value of sine 60 degree? If you go back to the table, sine 60 degree is root 3 by 2 and cos 60 degree is half. So this is 3 by 4 plus 1 by 4, which is equal to 1. 4 by 4, which is 1. Okay, so this third one is cos square x degree minus sine square x degree. Cos x degree square minus sine x degree square. Cos x degree is cos, what is the value of x here? 60 degree. Okay, cos 60 degree you know is half. No, cos 60 degree is, yes, cos 60 is half and sine 60 is root 3 by 2. So this is 1/4 minus 3/4. Now you take the LCM, 1 minus 3 by 4, which is minus 2 by 4, which is minus half. Okay, so that is, these are the values. Once you determine x, now you keep putting the values. Again, this problem is very similar to the problem that I did. Here only sec theta is equal to cosec theta is given. Okay, you need to find the value of theta. This is as very simple. You just change sec and cosec to cos and sine respectively. Given sec theta is equal to cosec theta. So for sec you write 1 by cos and for cosec you write 1 by sine. So you get sine theta is equal to cos theta, which means tan theta is equal to 1. Sine theta by cos theta is equal to 1. That means tan theta is equal to 1. And what value of tan is 1? It is 45 degree. So you can, instead of 1, you can write tan 45 degree. And therefore theta becomes 45 degree without cancelling tan. Okay. So that is the value of next number 9. Important problem. Sin a plus b is given to be root 3 by 2. Okay. And it is given also it is given that cos a minus b is also root 3 by 2. Okay, where a plus b is an acute angle. That means 0 less than a plus b less than 90 degree. Now if a plus b is acute angle, that means a minus b also has to be acute, right? This is very obvious. If the sum of two numbers is less than 90, then the difference also has to be less than 90, right? So say a minus b is also acute. That goes without saying. Once they have given a plus b is less than 90, that means a minus b has to be less than 90. Okay. And also they have given a is greater than b. Fine, no problem. A is greater than b. You need to find out the values of a and b. Now see here, sine a, we start with sine a minus b is equal to root 3 by 2. The first one means sine a minus b. What value of sine is root 3 by 2? It is sine 60 is root 3 by 2. Sine 60 degree. That means a minus b is 60 degree. Call this equation number 1. Okay, next sine a cos a minus b. Oh, this is sine a plus b. Sorry, my mistake. This was a plus. So all this will be plus. This will be plus, plus, plus. Okay. Next is cos A minus B is given. So we start with cos. Second one. What value of cos is root 3 by 2? It is cos 30. That means you get A minus B is equal to 30 degrees. So what are you getting? You're actually getting two simultaneous equations in A and B. And how do you solve these two simultaneous equations? If you remember, in order to solve these two simultaneous equations, you first add the two equations. Whenever you get simultaneous equations of the form x plus y and x minus y, you first add, this cancels, so you get 2a is equal to 90. That means E you are getting 90 by 2, which is 45 degree. And also you subtract. In order to get the value of B, you subtract. So A cancels here. So you get 2B is equal to 30. You get B is equal to 30 by 2, which is 15. So you have got the value of A and B as A you have got as 45 degree and B you have got as 15 degree. That's it. Now the next problem, number 10 here. Number 10 is a problem that we have done in rectilinear figures, if you remember. The last problem in rectilinear figures that we had discussed, if you open that video of rectilinear figures, I had solved that problem that time by the properties of rhombus, and I had mentioned to you that it's you can do the same sum very easily by trigonometry. So now the time has come to solve the same sum by trigonometry. You need to find, this is the rhombus given to you. Okay, what is a rhombus? It is a parallelogram in which all the sides are equal. So ABCD is a rhombus. So clearly these sides are equal. Okay. And these two, you need to find out the length ratio of the lengths of the diagonals. This is one diagonal here, and this is another diagonal here. You need to find out the ratio of their lengths. Say this is O. Okay. Now see, the two properties that I'm going to use here of rhombus before proceeding with trigonometry is that the diagonals of a rhombus are perpendicular to each other. So AC perpendicular to BD. Okay, that means this angle is 90 degree because diagonals of a rhombus are perpendicular bisectors of each other. We don't need the bisector part, we simply need the perpendicular part. That is why 90 degree. Perpendicular bisectors of each other. Okay. So AC is perpendicular to BD. This is part is okay. Next is that it is given to you that angle A is 60 degree in this. If you see, this information is given to you. So this angle clearly is your 60 degree. Okay. That means what is this angle? This angle has to be 30 degree. Why? Because again we use the property that the diagonals of a rhombus bisect its interior angles. So therefore we can write angle OAB is equal to half of 60, which is 30 degree, because diagonals of a rhombus bisect its interior angles. Okay, so this is 30 degrees. So once we have got, now what you see is that this triangle becomes a right angle triangle, and the question here is to find out the ratio of the lengths of the diagonals. Okay, so now look at it this very carefully. Suppose I take the length of all the sides of the rhombus as A. Okay, so this AB here becomes the hypotenuse of this right angle triangle, right? I repeat, this AB becomes the hypotenuse of this right angle triangle AOB. Okay, so now you can take the other two sides as your perpendicular and base, depending on which angle you are talking about. Okay, so what do we have to determine here? What do we have to determine here? Now see, if I take this angle here, 30°, what is the sine of this angle? The sine of this angle will be perpendicular. Sine 30 will be perpendicular by hypotenuse. That means this side perpendicular. That is because this side is opposite. This becomes the perpendicular and hypotenuse by this side. So therefore, if I take sine 30° is equal to perpendicular by hypotenuse, which is, and
Taking sine
mhm,
as 30.
sine
Sorry,
30,
sorry. Theta 30.
sine 30, yes, theta is 30 here.
Okay.
Okay, so now sine 30 is perpendicular by hypotenuse. Perpendicular here is OB, just opposite to the 30° angle. That side that you have is your perpendicular, and hypotenuse here is AB. Okay, and OB I need to find out. OB I don't know. And what is the length of AB? It is A. We have taken A, so that means sine 30 is OB by A. And what is the value of sine 30? We know sine 30 to be half OB by A. That means what is OB? OB is A by 2. That means this length here is A by 2. That means what is the entire length? What is the entire length DB or BD? Double of OB, right? The length of the diagonal BD will be double of OB, because you know that the diagonals are perpendicular bisectors of each other. So if this is A by 2, this will also be A by 2, right? So therefore, what is the length of BD? It is A by 2 plus A by 2, or 2 into A by 2. Therefore, BD is twice of OB, which is twice of A by 2, which is A. We have got the length of one diagonal. Now we want to find out the length of the other diagonal. In order to find out the length of the other diagonal, see that if I consider the same angle but with a different ratio, cos 30. This time if I consider cos 30, what will happen? Cos 30° is equal to base by hypotenuse, right? In this case, what is the base here in this triangle? If you see, if this angle we have considered, then this clearly becomes your perpendicular. This becomes your base, OA. Okay, so OA is your base. Hypotenuse remains AB. So OA is your base and hypotenuse remains AB. We don't know the side OA, so we simply write OA, and A, this we have taken as A. So what is happening here? We are getting cos 30° is equal to OA by A. Okay, and what is the value of cos 30? It is root 3 by 2 from the standard ratio table, OA by A. So how much are we getting the length of OA? If you cross multiply, you get root 3A is equal to twice of OA. Get twice of OA is equal to A root 3. That means OA must be equal to A root 3 by 2. So what have we got? What length have we got? We have got this length as, we have got as A root 3 by 2. So what is this length? This length is also A root 3 by 2. So therefore, what is the length of the other diagonal? AC. It is A root 3 by 2 plus A root 3 by 2. Therefore, length of the diagonal AC is twice of A root 3 by 2, which is simply A root 3. Now we can find out the ratio. Therefore, what is, we have to find out the ratio of what? We have to find out the ratio AC is to BD. Therefore, AC by BD. What is AC by BD? AC we have found A root 3, and BD we just found above to be A. So these two cancel. You simply get root 3. So what is the ratio here? AC is to BD is equal to root 3 is to 1. Okay, same problem we had done in rectilinear figures, different way. Here trigonometry, it becomes a little easier because we are using the ratios. Okay, so let us move on to the next easy problem, that is number 11. If you look at number 11, it is given that AP is a man of height 1.8 meters, say a man of height 1.8 meters here. Okay, so AP is a man of height 1.8 meters, and BQ is a building here. This is your ground level. Okay, so this is your PQ is a building 13.8 meters high. So this length is 13.8 meters. If the man sees the top of the building by focusing his binoculars at an angle of 30 degrees, say a man is standing here, so at P, he has his eyes at P, and he has the binoculars here, and he's observing the top of the building. This top Q he is observing. Okay, this is the line of sight. It's actually called the line of sight. Okay, observing the top of the building by focusing his binoculars at an angle of 30 degree to the horizontal. So this is your horizontal. At an angle of 30 degree to the horizontal, he is observing this man here is observing the top of the building here. Find the distance of the man from the building. Now, what is the distance of this man from the building? Distance of this man from the building is AB. Okay. If you call this point as C, then you can also say this is PC also, this distance. So whether you say AB or PC, it's the same thing. Okay. So now that means you need to find AB or PC. So let us find PC. If you want to find PC here, if this is the angle, then this is the right angle triangle PQC. This right angle triangle that you see here PCQ. This is 90 degree here. So this is a right angle triangle. And if this angle is 30 degree, then this must be your perpendicular, and this must be your base. That means, and how are perpendicular and base related? They are related by tan. So we start with tan 30 degree is equal to perpendicular by base. And in this right angle triangle, perpendicular is QC and the base is PC, the length of which we need to find out. Okay, and what is QC here? QC is, if this is 1.8 meter, this is also 1.8 meters. That means QC, this length is 13.8 minus 1.8, which is 12. So 13.8 minus 1.8 divided by PC. This length we don't know, we need to find out. So we get 12 by PC. So what are we getting here? We're getting tan 30 is equal to 12 by PC. And what is the value of tan 30? Tan 30 is 1 by root 3. 12 by PC. Now you cross multiply, you get the length of PC as 12 root 3. So what is the distance of the man from the building? It is 12 root 3. And I told you, you can remember the value of, if it is given in the problem, find the value correct to 2 decimal places. Then you will substitute the value also of root 3, even if it may not be given, which is 1.732. And once you substitute the value of root 3, you get the length of PC as 20.784 meters. So that's it. Okay. Any questions? Or otherwise, I'll stop here for today.